All right, so I'm back in my studio and I want to show you something. This is on the ebikes.ca website, Grin Technologies website. If you go to Tools, Motor Simulator, you get here. And I've already kind of set this up a minute. Basically, I use a 52 volt, 17 amp hour down 2 battery, but I chose 16 amp hour because it's the closest. For controller, I'm actually using the same controller I was using before, which is a 35 amp Grinfinion controller, basically. This is the MOSFET rating. And I have a 29-inch wheel and grade 0. And what this allows you to do is kind of do a system comparison between two motors, right? So obviously the battery's going to be the same, the controller's going to be the same, we'll use the same throttle output, same wheels, blah, 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 blah. I'm in the US, so I'm going to use miles per hour for the axis unit. But what this shows you is it shows you the newton meters of torque per speed, right? It shows you the efficiency curve, it shows you the power curve, and then the load, right? So where you see the power and the load meet up, right? That's the maximum speed, more or less. So the two motors I was choosing between were the GMAC 8 turn and the GMAC 10 turn. And per the Grin website, they consider the 10 turn to be what you would call standard winding, whereas the GMAC 8 turn would be considered fast winding. So the 10 turn is kind of more or less based around 26-inch wheel, 29-inch, 700C, whatever you want to call it. Whereas like an 8 turn is going to be for like a 20-inch wheel. But that's kind of, I would say their rating is based on like a 36 volt battery. So you would use a 36 volt, you'd use a 10 turn GMAC motor with a 36 volt battery because that would give you more torque, right? With less volts. And then, so for example, I built an e-bike for my friend Laura a long time ago. It was a cruiser bike, single speed cruiser bike, front hub. And I chose actually a MAC motor. It's not a GMAC, it's a MAC 8 turn because I wanted her to have, I didn't want her front wheel to spin out too much, but I also wanted her to have a decent top speed. So I chose the MAC 8 turn for that particular build. And on this one, I was torn between the two, right? And the reason being is because most people want torque, right? They, I won't mention names, but there's so some people, particular mid-drive people that, think that torque is the best, and that's, you need to have this, fast, Dodge Challenger to like, it's not the same as like a Volkswagen Bug or something, right? But what I want to show here is this is actual data. This isn't hype. This isn't trying to confuse anyone. What this is this shows exactly what we're looking at here. And a 10 turn has 100, we'll say 102, 101, 102 newton meters of torque to start out with, and then the GMAC 8 turn has 81 based on my battery and controller configuration. But you'll also look that once we kind of get into the 10 miles per hour range, those numbers start to come together, right? The efficiency band across the board is pretty close. Power band, all of that's pretty close. The difference being that the 8 turn has a top speed of 33.2 miles per hour versus a 10 turn, which has 28.7 miles per hour top speed. But you can also see that going above 30 miles an hour is terrible, right? And the efficiency is terrible. So you're far less efficient going 30 miles or 33.2 miles per hour wide open at 100% throttle versus the 10 turn, which only can go up to 28.7. So if you're going wide open, you will have more range, but you won't be going as fast, right? Another thing to note is the final temperature. So these are both geared motors, whereas I'm used to direct drive motors. So geared motors don't dissipate heat as much, but either way, both of these, in my opinion, are still too hot, but I would never go wide open for 18 miles anyway, right? It doesn't happen. So let's actually go with the motor that I've done all my touring on, besides the beginning ones. This is the Crystalite H3540, right? So we do that simulation, and we see that the motor I'm used to has very, very, very slightly more torque at the beginning, but it drops off because it's a direct drive motor, just like all direct drive motors. And the GMAC still has the same amount of torque all the way up to like 10 miles an hour. But you can also see that the GMAC motor is far more efficient across the board. That's the light green up here, right? And it's kind of hidden, but the Crystalite efficiency curve is right here. So the GMAC is actually still pretty much more efficient across the board, and it's still actually going to have more torque because it has continuous torque up until 10 miles an hour. But now let's compare my motor that I did most of my touring on with the other motor I had, which is this one. It's a 9-continent RH212 motor, and this is the one that actually failed me. But let's do a simulation and see what it looks like. So that motor has a lot more torque, but it doesn't have as high of top speed, right? So it's actually closer to a 10 turn. So the 9C RH212 and the GMAC 10 turn are actually more comparable. And actually we can show that. Just do that right here. They're more comparable, but yes, the 10-turn geared motor is going to have more torque across the board. It's going to be a little bit more efficient, right? But they have very similar top speeds. But one thing to note is, being that the 9C is a direct drive, you'll see that the temperature is actually a lot lower, even though the consumption rate is the same. The watts are very similar. Efficiency is very similar, right? The point I want to make here, though, is that when I went from a eBay crap motor, and then I upgraded the controller, and then I got the computer, and then I got into touring after I did a couple of tours on like kind of like shakedown tests, and I realized I wanted to have a temperature sensor. So this is the motor I chose, and what I did when I actually got that motor, I found the initial torque to be too high. So I actually went into my cycle analyst and I changed what's called the up rate, which is no matter how hard you mash the throttle, it applies a more gradual curve to the throttle response, right? And when I switched back to my Crystalite motor, I actually totally forgot to change that. And so I've actually been riding with this also limited, the up rate. So my main point here is going back to System B now being what I've been used to for all my tours, and what I chose, which is the GMAC 8-turn. I'm going to have a little less torque, but for longer, continuous, and my efficiency is going to be, let's see, it's going to be better, right? Because I like switch this around. Sorry, I'm not trying to confuse, but now the GMAC is the darker line. So this is actually it's still more efficient across the the band, and the power is still better across band, and it's only, a mile an hour slower, right? But it can reach temperatures faster. So I'm showing this because it was a hard decision between the 8-turn and the 10-turn, because you would think, touring and that's what this is specifically designed for, is actually like cargo bikes, touring, things like that. I also commute, 90% of the time or more, right? And I like going fast. Like, I don't go fast all the time, but I like being able to go fast when I can, and I think being limited by my top speed would be annoying, considering I've been used to being able to go 34 miles an hour. So this is kind of like still better is what I'm saying. I don't have a crazy ton of torque at the beginning, right? But I have a higher top speed, and I'm still more efficient than what I've been used to, right? And I have more torque for longer as well. So all around, performance is still better, except for like dissipation of heat. But that's about it. It's still more of an efficient motor, right? 43.4 is still more efficient. Like, it's 2 miles more range, right? But I guess my point is that I'm actually really comfortable with this torque, because if I want to go faster, I'll, like, off the line, I can just punch it and I can get up on my bike and I can pedal. And that still makes me go very fast. So yeah, so I'm showing this because this is data, right? This is like undeniable data versus, hype or trying to make something sound cooler than it is or not, or say one thing sucks and one thing doesn't. What this shows me is that I'm getting the same and better performance, more efficiency, basically the same top speed, and I'm actually using a little bit less power, right? But it's more efficient. And for this build in particular, I'm trying to not only be happy with commuting, but I also want to be happy. Another factor, I guess is what I'm trying to say, is that more torque equals more stress, we'll say, right? I'm very familiar with drag racing and cars and things. I used to race all the time. And they say, I watch this guy, Cletus McFarlane, and he's awesome. But, one of their slogans is like, bent rods and dad bods, right? The whole idea about racing is, you race to break stuff. And then you upgrade it, and then you race until you get to that limit, and then you break it again, and then you upgrade that. And that's like your upgrade path, right? What I want to do with this build is I actually want to make it as safe as possible, to where nothing is going to break, nothing is going to overheat. It's never going to be pushed to its limits. I'm sticking with 35 amps rather than going to 52 or 50. I'm going a 52 volt battery versus, like, say 72 volts. And I'm choosing the faster winding, which is going to have less torque on the offset, because that's actually going to be less stress on the motor, on the gears inside the motor. So actually, in my opinion, for longevity and what I do, my particular use case, which is mostly commuting and some touring, that this is this is all around better for me and my use case. It might not be able to do burnouts in the gravel, but I can go 33 miles an hour, right? And also that means that I'm not going to be wearing down the nylon gears as fast, and I'm not going to be going 33 miles an hour all the time, right? But I can still, it's still the same performance that I'm used to with this other motor, right? And so I can use that from my own personal experience using both the Crystal Light and the 9-continent motor. I dialed back, or what in the racing community would do, you could you know people tune their cars because they it's not just about applying all of the power. It's not like you can just come up to the line and then just punch it, right, with everything wide open. You go in and you dial back, and you change the performance based on the gears, making sure that you can not wheel spin, and make sure you're not breaking stuff, right? It's the same as here. Like one of the this just comes down to a choice, right? So I'm choosing kind of more of like extended gearing, I guess we'll say at the beginning, so that I can still achieve a decent top speed where I'm happy, right? But I'm also happy with the amount of torque that I'm able to apply at the beginning, and I have more torque up until 10 miles an hour. It's the same. It's because it's a geared motor, it's going to have more torque for longer up until 10 miles an hour. And going back to the 10 turn, when you get to 10 miles an hour, you're really close anyway, right? So yes, right off the bat, you're going to feel that torque, you're going to feel that extra oomph, and it's going to feel really, really zippy. But when you're touring, that's not what you're looking for. You're looking for efficiency. You're looking for range, and you're going 5 to 14 miles an hour. Like that's what you do. So I feel like this is actually the right choice. And it might seem weird, choosing a faster motor for touring when I'm going to be going slower speeds. But like I said, I commute 90% of the time. And so it makes sense for me to choose a motor that I'm able to comfortably go faster, and also have a little bit lower torque so that I'm not pushing the components inside my motor as hard, because now I am going to be dealing with gears because it's a geared motor. So anyway, that's my choice. I was having a conversation with my mom and my dad, and my mom being obviously the angel shoulder, which is get the slower motor because you don't need to go 30 miles an hour, and then my dad's like, of course, no, you want to go fast, and they're both right. And looking at the data, I'm not really compromising as much as some people would think. 80 newton meters of torque is actually totally fine, and yes, 100 plus is better, I guess, if you like that, but that is putting a little bit more stress on those components. They are identical, so the nylon gears aren't better in the more torquey motor. They're the same nylon gears. So in my mind, I see it as a win in that I'm not pushing those gears as hard off the line. And I'm using them both. I would be using them both kind of in the same power curve here, right? This power curve. So anyway, that's my argument. Take it or leave it. It doesn't mean I'm right. I guess we'll see. Haven't got the motor yet, but that's that's where I'm at with that. So at least hopefully this helps understand my choice and why, and also kind of explain general, torque versus efficiency versus power, so that other people can make their decisions as well.